Consider another example on normal distribution. So here, let us see what is the given mean value mu and standard deviation. Average lifetime of the bulbs is given as 2040 hours. So this is the required mu, mean value or average value mu is given, and the standard deviation is of 60 hours. So this is standard deviation sigma, which is 60, and the mean mu is 2040. Now we use the standard normal variate. Based on this data, we try to calculate one by one. So we know the formula for converting normal distribution into z variable with standard normal z variable z. This z is equals to x minus mu by sigma. And here you know mu and sigma values, which is x minus, what is the mean mu is 2040 and standard deviation is 60. So this comes as x minus 2040 and divided by 60. Let it be equation 1. Now coming to the first question, which is more than 2150 hours. So first question, we have probability of lifetime of the bulb having more than 2150 hours, more than 2150 hours. If I indicate x as the lifetime of the bulb, so I can write this as probability of x more than 2150, that is x greater than 2150. Now we have to apply this formula, x is minus 2040 by 60 for this. So when I substitute x as that, the corresponding z value comes as 2150 minus 2040 divided by 60. And when you simplify, z value comes as 1.83. 3 is a recurring digit. I will stop at 1 decimal place. So 1.83. So saying x greater than this one, saying x greater than 2150 is same as of saying z greater than 1.83. So probability of x greater to 150 is same as of calculating z greater than 1.83. Now let us see how do you calculate this by using normal distribution table. And before that, let me draw the normal curve. Now so z is equals to 0 is the central line, and because I have z is equals to plus 1.83, I am taking this z is equals to 1.83, right side of this z is equals to 0. If we have minus 1.83, then you have to point the z is equals to minus 1.83 left to this line z is equals to 0. Okay. Now we want to calculate here, this is probability of z greater than 1.83. Z greater than 1.83 means z values which are more than 1.83. So towards the right side you will have z values more than 1.83. Left side it is towards z is equals to 0. That means z values will be less than 1.83. And towards the right side it is up to infinity. That means z values will be more than 1.83 and up to infinity. That means this is the required area for this problem. And how do you get this area? I already told you a number of times. You are supposed to remove this area from the total area of 0.5. But how do you get this area to remove? This is area, this is nothing but area from 0 to 1.83. Go to the normal distribution table and see what is the area from 0 to 1.83. See the normal distribution table we have. Here we have 1.8, and the second digit you have to see in the column wise. This is 3, so 1.83 will have 1.8 and the 3. This is 0.4664. So this is 0.4664, and we know total area from. Let me remove this. Okay. Let me remove this, and this is total area from z is equals to 0 to infinity, this total area is going to be 0.5. So this total area is 0.5 and this area is 0.4664. I want this area, so what I will do, I'll remove 0.4664 from 0.5 total area, so that required area is going to be 0.5 minus 0.4664. When you simplify this, it comes as 0.0336. This is actually the probability value. But look at the question. In question we have this 2000 such bulbs are purchased. I mean the sample size of 2000 is given. Now we got just a probability value. We are supposed to use this probability value to estimate out of the 2000 bulbs how many will satisfy this ratio. So out of 2000 such bulbs, this ratio comes as 2000 into 0.0336, approximately this is 67 bulbs. So this is your required answer. To see the next question in this. In this case, less than 1950, that means x less than 1950. Using z is equals to x minus mu by sigma formula, substitute x as 1950 and mean is given already 2040 and the standard deviation 60. When you simplify this, you will get the z value as minus 1.5. This is saying x less than 1950 is same as of saying z less than minus 1.5. So now we have to calculate probability of z less than minus 1.5. Observe, saying z less than minus 1.5 is same as of z greater than plus 1.5. That means area right to plus 1.5 or area left to minus 1.5. This area. These two areas are same only, but better to start with 0 to positive 1.5. Both are same, no problem at all. So we have to calculate area between above 1.5. This you can do it by subtracting total area 0.5, which I explained already in many videos. Just go through that and see, will give you probability as 0.0668. But we want out of 2000 what is the total bulbs satisfying this probability. So you'll get on multiplying 2000, 134 such bulbs. Next question. In between 1920 to 2160, there is so for 1920, if you apply this formula x minus mu by sigma, you get the corresponding z value as minus 2, and when you apply this 2160 with x minus mu by sigma, you will get the corresponding z value for this 2160 as plus 2. So we have to calculate the area now in between minus 2 to plus 2, that is z is equals to minus 2, which is written left side to this z is equals to 0, and plus 2 is written right side of the z is equals to 0. Now observe, this is one area and this is one more part. So this is part 1 and part 2. We want the complete area from minus 2 to this end to this end, right? So because these two areas are equal, if you calculate one area and multiply by 2, it will give the same answer. So area from 0 to 2 we can calculate and multiply with the 2, because the minus 2 to 0 and 0 to 2 both are same, so 2 times. And from normal table you will get this area from 0 to as 0.4772. Go to the normal distribution table and 0 to 2.0. This is the first column, 0.4772. And when you multiply with 2 on the remaining answer, you get it as a 190. So just go through the previous video for the next